Welcome to Ask and Learn.
Let's use the ratio test here to determine which values of k make the given series convergent. So here, this will be our an. So for the ratio test, we know to look at the limit n goes to infinity, absolute value, an plus 1 over an. So we can drop the absolute value here because n and k are positive. So an plus 1, I'll do this in red. This is n plus 1 factorial and square that. For the denominator, just replace that n with the n plus 1. And then we'll go ahead and divide that. And now using blue, we'll just write our an. N factorial squared, kn factorial. And now, as usual, when you're dividing a fraction by another, just go ahead and flip that blue fraction upside down. But also here, let me just rewrite. I'll use the fact that n plus 1 factorial, by definition, it's just a product of the first n plus 1 positive integers. But if I group the first n, I can just rename that with n factorial times n plus 1. So I have n factorial times n plus 1, and that's being squared. And the denominator, I'll just leave that for right now. And then I'll flip this fraction upside down and multiply that. And you could kind of see why the reason for doing this over here is that it allows us to cancel this n factorial squared with this n factorial squared, leaving us with the limit n goes to infinity, and then we'll have n plus 1 squared up top. And now in the bottom, we're looking at the fraction kn factorial over kn plus 1 factorial. Now, if I were to write each of these out using the definition, the top is just the product of from 1, 2, all the way to kn. The denominator, well, kn is less than k times n plus 1. So eventually I'll come across these terms, and then I'll keep going until eventually we reach kn plus 1. And by writing it this way, you see you could cancel the first kn. And so that just leaves us with this in the denominator. Now, when we go ahead and take this limit, so k is a positive integer, so the smallest k to consider would be k equals 1. However, if k equals 1, then in that case, so this is going up to kn. If I multiply that out, this is kn plus k. So if k equals 1, the last term is just the first term, so that just means there's only one term. So if k is 1, the limit is the limit of n plus 1 squared over n plus 1, but that goes to infinity, which is bigger than 1, and so it diverges in that case. So we do not want k equals 1. Now if k equals 2, then we would have n plus 1 squared over, so now we would have 2n plus 1, 2n plus 2, and one could use L'Hopital's rule here to see that this limit goes to 1 over 4th, which is less than 1. So k equals 2 will give convergence. And similarly, here's the key step here. If k is bigger than 2, then the denominator has degree k, which is also larger than 2, because you'll be multiplying k terms here. Just like when k was 2, we'll have 2 terms. And if k was 3, you would have 3 terms. Since the denominator has larger degree than the numerator, that will mean that the limit of an plus 1 over an is 0, which is less than 1. And so by ratio test, that means convergence. So k bigger than 2 or equal to 2 gives convergence. So we will go ahead and leave as our final answer k larger than or equal to 2.